Alright, yo, this is Mr. Veenstra. I'm currently wearing a big yellow minion costume, and I'm going to do some algebra. Here we go! Quadratic parent function. Remember, that is y equals x squared. That's the quadratic parent function. Parabola, that's just the U-shape. It's the U-shape that I make with my quadratic functions. It's the U-shaped graph, specifically. Graph. Vertex? Well, vertex is either the lowest point or the highest point. And you'll see all of these in just a minute on question number 10. Axis of symmetry splits the shape in half. The axis of symmetry splits the shape in half. Symmetric points, well, those are points on either side of the axis of symmetry. Symmetric points are points across the axis of symmetry. And again, you'll see these all in just a minute. Y-intercept, where it crosses the y-axis. The line crosses the x-axis, or where the y-axis. Don't be stupid, Mr. Veenstra. It's where the line crosses the y-axis. I was thinking it's where the x value is equal to 0. It's kind of backwards. The y-intercept is where it crosses the y-axis, but it's where the x value is equal to 0. Well, the x-intercept is where it crosses the x-intercept, x-axis, where the line crosses the x-axis, or where my y's are equal to 0. And then solutions are where my two lines meet. Two lines meet or intersect. It's where two lines meet or intersect. Alright, if you didn't get any of that, pause the video right now, copy it down. Because I'm going on 3, 2, 1, here we go. Number 9, which of the following will always be the same as the x-intercepts? Well, solutions are my answers, but they're not always the same as my x-intercepts. Roots is another word for x-intercepts, so that one. Zeros is also another word for x-intercepts. Y-intercept is never my answer. Please, when you get to the test tomorrow, do not choose your y-intercept. That's just silly. All right, number 10. Good, this is where I see all of these words come into a graph. So the shape of a graph, this U-shape, is a parabola. These 2 points where it crosses the x-axis are my x-intercepts, or my roots, or my zeros. Good. This bottom point right here is my vertex. This over here, this line that goes directly in between the shape, that is my axis of symmetry. This line where it crosses, this point where it crosses the y-axis is my y-intercept. And then finally, these 2 points that are on either side of the axis of symmetry are my symmetric points. I actually didn't mean to pause there. Mr. Veenstra just went full stupid and didn't remember what they're called. But then he remembered. Here we go. Number 11 and 12 and 13. They want us to write it in standard form. Remember, standard form is ax squared plus bx plus c is equal to what? 0. It is always equal to 0 in standard form. So this equation right here Is it equal to standard form? No, it is not. It's not equal to standard form. So, to get this equal to standard form, I need to add 6 to get rid of that negative 6. So I get rid of that negative 6 by adding 6. And if I do it on one side, I have to do it on the other side. So negative 6 plus 6, those two go away. Can I combine this 6 with an x squared? Nope. Can I combine this 6 with a 5x? Nope. So I just copy it down. I have 0 is equal to x squared plus 5x plus 6. Is that in standard form? Yes, I have it equal to 0, my x squared, my x, and my number. All right, next one. Number 12. Is this equal to 0? Nope. So I need to get rid of this positive 5x. How do I get rid of this positive 5x, you say? Correct. I subtract 5x. If I do it on this side of the equal sign, I have to do it on this side of the equal sign. So I subtract 5x. These two go away. Can I combine this 5x with an x squared? Nope. Can I combine this 5x with an 18? Nope. So I copy it down again. 0 is equal to, now remember, my x squared term comes first, then my x term, and then my number. So I have negative 2x squared. Then I have minus 5x. And then I have plus 18. Now that is in standard form, and I'm good to go. Now, this last one, number 13. Number 13 looks a little different, right? I have 3 steps that I have to get this into standard form. First of all, I have to square this part. You see how it's x minus 2 squared? Well, if I have something squared, I can use my box method. I have x minus 2 on top. And because it's squared, it's another x minus 2. Cool, so what is x times x? X squared. X times negative 2. Negative 2x. X times negative 2. Negative 2x. And finally, negative 2 times negative 2, I get positive 4. So, I just replaced everything that was in here. So don't forget that negative 3. Then parentheses, I take my product, what was on the inside. So I have x squared. Well, I can combine these two, right? I have negative 2x and negative 2x. I combine those, I get, yay, minus 4x. And then plus 4 at the end. And don't forget the extra plus 4 that's at the very, very end. Remember, this plus 4 came from our box multiplying. This plus 4 came from over here. This is all equal to 0. All right, well, now I have this negative 3. I can distribute this negative 3 into my parentheses. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 4x, negative 3 times negative 4, I get positive 12x. And then I have negative 3 times positive 4, I get negative 12. Don't forget this plus 4 at the end still equals 0. You see how I only distribute this negative 3 to the parentheses? I do not distribute it to this 4 that's at the end. And then finally, I can combine these last two terms over here. So I get, drum roll please, negative 3x squared plus 12x, negative 12 plus 4, minus 8 is equal to 0. That is my final standard form. All right, we're cruising. Next page. Number 14. Oh, this was just like our assessment, right? Write the letter of each graph for each statement which is true. So the first one, I want to know which function or functions has exactly 1 0 at f of x equals 0. Well, two things, right? Zeros are my x-intercepts. INT just means intercepts. I'm abbreviating it. and f of x equals 0. That's like saying y equals 0. So I have the line y equals 0 right there. And on this graph, it's right there. And on this graph, it's right there. And this graph, it's way over there. It's just the x-axis. So I want only one x-intercept. How many does this have? 1, 2. Doesn't work. How many does this one have? None. That one doesn't work. How many times does this one have? 1. You see how this parabola touches my line once? So I know C works. What about D? It touches once, twice. No can do. So the only one is C. Next one wants to know exactly one solution at y equals -2. So I draw my line at y equals -2. Oh, that was a bad line, Mr. Veenstra. These should touch. And then I have a line over here. And then I have a line down here. And a line down here. Alright, which ones only touch once? Good. A and B. Should be pretty familiar to you. We've done these a bunch of times. Alright, the next one asks which one has 2 roots. Remember, roots are x-intercepts. So which one has 2? This one has 1, 2. This one has 0. This one has 1. And this one has 1, 2. So my 2 graphs that have 2 roots are A and D, because this one touches the x-axis twice, and this one touches the x-axis twice. Which one has no solutions at y equals 0? Well, again, that's my line going all the way across. So the only one that has no solutions, the one that doesn't touch, is B. And then finally, which one has zeros of the function that are both positive? Well, A has 0 and then some other positive number. So I'd count that one. B doesn't even touch, so I don't have to worry about that. C has 1 negative over here. Has a -0. And this one has a positive and a positive because they're over here to the right. So D also has 2 positives. Alright, here we go. I even took off my shoes. We're getting real serious up in her. Number 15. I want to know the x-intercepts for this quadratic function. Well, if you were to know anything for this test, it would be this question right here. This question right here is like the one thing we've been learning forever and always. So, if I want to solve this and get all my points, I have to factor this guy. So remember, I list my A, my B, and my C. My A is 2. My B, remember, is -1. Don't put a 1 there. Make sure you put a -1. And my C is -3. So I put it in my box. My first term goes in this first box, 2x squared. And my last term goes in this last box, -3. Then I take my A times my C. 2 times -3 gets me -6. I want the factors of -6. What 2 things multiply to give -6? Well, remember, I could do this in my calculator if I wanted. I do -6 divided by x, go to my table, and list out my factors. We become pros at that. I'm just go ahead and list them because I'm smart and I know them. I have +1, -6, +6, -1, +2, -3, and +3, -2. And remember, I want to see which one adds up to equal my B value. Which one of these pairs adds up to equal -1? Cha-ching, my 2 and my -3. So, and it doesn't matter what order I put them in. I put my 2x here and my -3x here. Don't forget to put those x's with them. Again, it doesn't matter if I'd put the 2x here and the -3x there. Does not matter. You'll get the same answer. Alright, what do these two have in common? Well, they both have an x. Ooh, voice crack. And the biggest number that divides in there is just a 1. So it's x. So, x times what gets 2x squared? 2x. 2x times what gets 2x? Plus 1. And then x times what gets negative 3x? Negative 3. So my factors are x plus 1 and 2x minus 3. Now remember, I'm finding x-intercepts. Well, to find the actual x-intercepts, I have to set this factor equal to 0. That's the last step that I have to do. I set them equal to 0. Alright, well, if I want to get x by itself, I do minus 1 over here, minus 1. These 1's cancel. I get x is equal to negative 1. Over here, it's a little bit more complicated, but only a tiny bit. I add 3. I add 3. I get 2x is equal to 3. Then finally, I divide by 2. Divide by 2. And I get x is equal to 3 divided by 2. So this is one answer, and this is my other answer. Remember, I just set them equal to 0, and I solve for x. Pretty simple stuff. And finally, number 16, I have a table that shows the values of this equation right here. If I have negative 5, 4, 3, 2, 1, 0, 1, and then all these values over here. So this one wants to know the roots of the equation. Well, remember, roots are my x-intercepts. My x-intercept is where my y is equal to 0. So I go right here. Here's 1. And then here's another one right here. Remember, I have to look and see if there are 2 answer choices. So my answers are x equals negative 4 and x equals negative 1. These come from these points right here, because remember, my roots are my x-intercepts, where my y value is equal to 0. Well, this one is wanting solutions when this equation is equal to negative 2. Not when it's equal to 0 like it was before, but when it's equal to negative 2. So where am I equal to negative 2 over here? Correct. Right here and right here. So my x values are negative 3 and negative 2. Easy stuff if they give you the table or the graph. And finally, the last one is a tad bit different. I want to find g of negative 5. Well, usually I have an x right where that negative 5 is.
Jennifer Aguilera,
so, oh no.
Report to the AP's office. Jennifer Aguilera, please report to the AP's office.
Jennifer, you ruined my video. You're in trouble. Here we go. So x is actually equal to negative 5. So I want to find my y value when x is equal to negative 5. Go to my table. Where is x equal to negative 5? Boop, right there. So my y value is 4. Y is equal to 4. That's my answer for the last one. Cool, here we go. We're making record time on this. Alrighty. Number 17. Table shows values for a quadratic function. If negative 4 is one of the solutions to f of x equals 0, I want the other solution. Well, it's telling me I have the point negative 4, 0. Let's go ahead and put this point on the table, even though there's no room. Well, negative 4 would be up here. It would be the next x value right here. That means 0 would be that value. Well, let's look for patterns. Cover this up. What do I notice about all of these values right here? I notice that there's a pattern. They repeat like this. You see how they keep repeating and repeating? So if I continued this pattern, this 0 that I just drew in would be my next value right here. Well, look at the pattern over here now. You see how this is going by 0.5s up, 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 up. So if I increase one more by 0.5, I hit 1. So it told me that this was an answer. I want to find my other answer. Well, here's my other answer. I just found it by using patterns. So my other 0 is 1, 0. 18, 19, and 20, I'm going to solve a couple of them. You have to solve some of them on your own. I'm going to give you the answer, but for you to actually be able to know how to solve them, you need to try it on your own. 18's easy, right? It already factored it for me, and I know it's equal to 0. So I have 5x plus 2 is equal to 0, and x minus 8 is equal to 0. So if I want to solve this one, I subtract 2, get 5x is equal to negative 2. Then I divide by 5. Sorry, it's getting real crowded up in her. So x is equal to negative 2 divided by 5. Don't forget my other one. If I want to get x on this one, I add 8. These cancel, so I get x is equal to positive 8. Positive. Number 19. How many roots does the following equation have? Well, here, I'm going to tell you to solve it this way. Draw a line through your equal sign, plug all of this into y1, plug all of this into y2. Go to your graph and figure out where they intersect. So go to graph after you do this and press second and then trace. From there, press number 5. And then you'll go back to your graph and you're looking for intersections. Well, you're going to have 2 of them, right? And where they meet is where my answers are. And so once you cursor over, you move your little arrows to get it close to it. Click enter, 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 and it'll give you a value. I'm not going to solve this one. I'm just showing you how to solve it on the calculator. So you're responsible for number 19. Right? You could also put this in standard form and solve it just like we solved number 15.
Aguilera, please report to the AP's office. Jennifer Aguilera.
Jennifer, just go to the AP's office so there's no more announcements. You're killing me, girl. Ah! All right. So you're solving number 19 on your own. Number 20, I want to find the solution to the following quadratic function equation. Oops. Well, me being a smart man looks at this and say, wow, that looks like a perfect square trinomial. Let's see, are there 3 terms? Check. Is the last term positive? Check. Can I take the square root of the first term? Can I take the square root of the last term? Yes. So, I can factor this without having to do the box. I can do what times what gets x squared? Good. X. So x goes right there and x goes right there. What times what gets 64? 8. And then what sign goes in between here? Whatever sign is right there. So I have plus 8 and plus 8. So if I'm looking for the solutions when g of x is equal to 0, I take one of these, because you see how they're both the same. X plus 8 is equal to 0. I subtract 8. I subtract 8. And I get x is equal to negative, well, that's not an 8. X is equal to negative 8. Excuse my really weird drawing of an 8. Kind of looks like Janice's face. Oh! Okay, here we go. Number 21. You're welcome, Janice. The length of Sandra's living room rug is 7 feet shorter than its width. All right, well, look at this. Pretend it didn't tell us this part right here. 7 feet shorter than. 7 feet shorter than means I'm going to take W and I'm going to subtract 7. Shorter than the width, so I'm going to subtract 7. So I'd write that as W minus 7. Now if I wanted to find the area, remember this is my length. The length is 7 feet shorter than the width. I need to multiply by my width, W. And it tells me that it's equal to 30. That's how I would set that equation up, right? The width times the length is equal to the area 30. Now to solve this, first I have to distribute. W times W is W squared and W times negative 7, ooh, excuse me, is negative 7W is equal to 30. Now this still is in standard form. I have to get it equal to 0. So let's move this positive 30 by subtracting 30 and subtracting 30. So I get W squared minus 7W minus 30 is equal to 0. This one you need to solve, and you need to pause the video right now. I'm not even going to tell you what the answers are. You need to solve and see if you get an answer. I just want you going through the process and being able to at least try the problem. No, really. Pause it right now and solve it. Do it. Don't be lazy. Alright, last two. Here we go. Use the graph shown to answer questions 29 and 30, but this is question 22, so this is wrong. The graph models A, the area in square feet of a rectangular porch, with the length that is 0.56 W less than, 28 feet given a width of W feet. Ugh, that's terrible. Based on the graph, what is the width in feet of the porch with the greatest area? Let's just look at this graph, okay? On my x-axis, I have width. This is my width, and it's going bigger and bigger and bigger. What do I have on my y-axis? Feet. Okay, and it told me I want what? The greatest area, the biggest area. Well, this graph represents my area. What is the biggest area as I'm going on this graph? I go up, 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 and then I start to go down. So my biggest area is at this point right here. It's 350. But remember, it wanted my width that was the biggest. So when I have the biggest area, I come over here, and I draw a line going down here. So my width at the biggest area is 25. Alright, according to the graph, at which width would the porch have about 350 feet of area? Alright, so only 300, sorry. So let's go to the graph, find area of 300, and let's just draw a line all the way across. So this is my line representing a porch with 300 feet squared of area. Well, don't you see how there's two possibilities? There's one right here, and there's one right here. There's two different things. Kind of looks like a face. So I can draw my line down from here, and my line down from here. That's a crying face. And my two widths are 15 and 35. So the widths are x equals 15 feet or x equals 35 feet. Okay, ladies and gentlemen, that's it. That's all I got for you. This was a shorter review. I went through it super quickly, but you should be able to go back and rewatch anything you didn't get. Slow it down, speed it up, fall asleep listening to it. But this is Mr. Veenstra, and this was my review. Bam!